All right. Hello, everybody. Let me turn the screen down. I always forget to do that. This is the first of a series of webcam vlogs that are low quality but very easy to produce, where I'm just going to be simply talking about topics. I just finished recording a 45-minute long video that was too long to apparently save correctly with YouTube. Um, but I think it's a good thing because that was a lot of information, and I think I can refine it to hopefully at least half the time. Uh, the first topic I want to talk about is what I believe is the basis for all other topics. I want to get to moral philosophy. I want to get to theoretical physics. I want to get to political science. There's a lot of things that I want to talk about. I want to talk about anthropology, linguistics. I want to talk about sociology, psychology. But in order to talk about all these things, I think it's really important to talk about rationality. Because if you don't understand the concepts of what rationality is and how thought works and how discourse works and why people make certain decisions and have certain beliefs, then it is impossible to go any further with any type of study. Um, so I want to first talk about the differences between living beings and computers and how they operate. Ultimately speaking, all computers need to operate is they need to be programmed with correct rules of mathematics. That's it. All computers need is a math book, and they can do anything. I'm going to give a really quick, simple example um, that is oversimplifying computers, but based on the example I give, it will give you an accurate picture of how computers work. So basically, all computers do is they look at an input and then they follow a step of algorithms to give a certain output. So a very simple problem that a computer would solve is if you ask a computer, tell me if this number is even or if this number is odd. And then you plug in a number, any number, and it tells you correctly if it's an even number or odd number. The way computers do this is by algorithms, and those algorithms are based on mathematical functions. Probably what a computer is going to do is it's going to perform some type of mathematical exercise on the number you give it, and then based on a set of criteria, it is then going to output correctly the answer that is correct. So I'm not exactly sure. I'm sure there are many ways that computers can do this, but just to give some examples of how just pure math can come up with the answer, um, a computer might take the number 3 and divide it by 2 and come up with 1.5 and then say, okay, because this number has a remainder, it is an odd number, and then take the number 4 and divide it by 2, come up with 2, and say because this number doesn't have a remainder, it is an even number. If for some reason the computer isn't set to figure out whether or not there's a remainder or not, another thing that it can do just by pure math is to take the number and round it. So take 1.5, round it down, so just chop off the remainder and get a 1, and then uh, double that number to get to 2, and then compare that to the original. Comparing 3 to 2, 3 is not equal to 2. So it will come up and say that it is an odd number. Whereas with 4, if it chops it in half, turns it to 2, and then gets rid of the point 0 at the end, then it will then double that number and get to 4, and it'll say 4 equals 4, and then thus it is an even number because both numbers are even, that both numbers are the same. So there's purely mathematical way how it figures that out. So that is the simplification. That's how everything that happens on a computer happens by that process. It's all math. Humans work differently. Now, of course, we could, in any situation, a human could work like a computer. The way that our brain works is not too different from what the way an inside of a computer works. But because humans, the human brain has been created biologically, um, and also has existed through a lot of experience, um, we typically look at a problem differently than a computer does. And the way that we're designed, um, humans probably a lot of times can arrive at the solution quicker using a different method than a computer would. Uh, so just like how when you're doing math by hand, you're doing it very different than a calculator would, but that's the fastest way you can do it. Whereas with a calculator, it has other ways of doing it. So looking at that problem specifically, how do you do that? You probably are saying, okay, you're probably remembering that numbers 1, 3, 5, 7, and 9 are all odd numbers, and therefore any number ending in those numbers is an odd number, and then any number not ending in those numbers is an even number. That's probably how humans do it. So in order to do that, we need to remember, first of all, we need to remember the sets of even and odd numbers correctly. If we're smart, we only need to remember one and then know if it is or it isn't, but we probably are remembering both sets and making it a direct assessment based on that without looking at if it's part of that set or not. And then we also have to know that we have to look at the number all the way to the right, the last digit in the number. For instance, with the number 121, we can't just look at the 2 and say, okay, that's the middle number, that's a 2, we know 2s are even, thus 121 is even. That's incorrect. We have to know to look at the last digit. So for a computer, this process is more involved, and if you were to program a computer to do it the way a human did, it would probably take a lot longer. First of all, it would have to have memory space. It would have to have memory space occupied to remember that a certain set of numbers are even and a certain set are odd. And then it would have to also have a way to figure out what the last digit in a number is. Because with a computer, it doesn't matter what the last digit in a number is. The number is a concept. So it's a lot easier for us to do that than a computer to do that. So for computers, it's the math. For humans, it's based on memory. It's based on knowing the difference between right and left. It's based on logic. It's much more complex. But that in that complex way, we would come up with the answer way faster than doing a mathematical equation. Now, of course, we can always do that equation to prove we're correct if we don't trust our memory or trust our ability to tell left from right. But typically, we don't need to do that because we just know. So that's how a human is different than, or a human or any living organism, the way it mentally processes is different from a computer. Now, because humans think more abstractly than computers, because we employ tools like memory and beliefs about ideas like left and right, things that a computer can't really quantify mathematically. We have to have a more complex system to think about things and to discuss things than a computer can have. And that system is rationality. It is basically based on the ideas of formal logic. And rationality, there are two types of rationality. One is instrumental rationality, and the other type is epistemic rationality. Instrumental rationality is about how to get from point A to point B, whereas epistemic rationality is about having a concrete belief about what's true or what's not true. So, for example, with an example of instrumental rationality is if you have a chicken that's crossing the road and it's thinking, I want to get to the other side, how do I do that? It has an equation in its head, and it's solving for the process, the algorithm that achieves the desired result. And of course, solving for an algorithm might be essentially way more complicated than solving for just a mathematical answer. Thus, you can't just use math, you have to use rationality. For example, you ask the question, how do I turn a 3 into a 20? We're probably going to say, well, you have to go through a few processes. The algorithm is probably to multiply it by 7 and subtract 1, which is way simpler, or multiply it by some funny number that has has digits, decimal places. Um, so that's what the chicken's doing, and that's instrumental rationality. Now, what the chicken's probably doing in its head is it's probably thinking some process like either from memory, I've done this before. I know that in order to get to the other side of the road, I have to cross it, and because it's done it before and it worked, so that's it believes that's the way to do that, so it's tested this. Or it just simply has a system in its head where it knows in all cases when it sees something, orients its body towards that thing, and then moves its feet one after another in that direction, it's eventually going to reach that thing. So that's instrumental rationality there. It's how do you get from point A to point B? How do you achieve a desired result? Epistemic rationality is about belief. So, for example, in the example that I gave with the even and odd numbers, you have to, in order to come up with the correct answer is 121 an even or odd number, you have to have a belief about whether or not 1 is an even number or 1 is an odd number. So we're talking about memory. I'm going to give a little thought experiment here. Say you take someone who doesn't understand math and can't count, and you ask them, you show them a number, the symbol for that number, and you say, is this number even or odd? Well, how are they going to figure that out? Well, in English, they probably even gives you the idea of something that's equal, flat, odd is different, weird. So they're probably going to think even means symmetrical, like an 8, and odd is asymmetrical, like a 7. So if you were to ask them, show them an 8 and say, is this number even or odd? They're probably going to say, well, this number's even. And you'll say, correct. And I'll say, okay. And then you give them 7. And you say, is this number even or odd? And they'll look at a 7. It looks a little weird. So they're going to say, this number's probably odd. And then you say, correct again. And then at this point, you give them another one. Give them a 9 and say, is this even or odd? Again, the 9 probably is asymmetrical, more kind of like the 7. Doesn't really look even. So they're going to say odd. Correct again. So at this point, they're going to say, I know what I'm doing. I know how to figure this out. I've done it 3 times. I've been correct 3 times. It's based on symmetry. But then what happens when you give them a 4? Well, they'll look at the 4 and say, oh, well, that's an odd number because it's not symmetrical. It follows the pattern. And you'll say, no, but you're incorrect. It's not. It's an even number. And you're like, well, what? So at this point, most people, if they're thinking primitively, will say, well, my view is still correct because I was right 3 out of 4 times. So there's something weird going on here. It's aberrant, but my system for figuring this out is still correct. Now, if you're applying epistemic rationality here, what you really should be doing is saying, well, I was correct 3 out of 4 times, thus I'm not probably correct. I'm 75% probably correct. My belief about the even and oddness of numbers and how I figured this out is 75% correct. Now, if you come up with, again, you say is 2 even or odd, and you answer, well, based on the theory that has been correct most amount of times, I'm going to say again that it's probably an odd number. But you're wrong. At this point, your ratio is 3 to 2, correct to incorrect. So at this point, you have to say, well, I've only been right 60% of the times. I have 60% confidence in the belief that numbers, even or oddness, is based on the symmetry versus the asymmetry of the symbol. So at this point, you have to say, well, there's probably something wrong about the way I'm looking at this. And at this point, you're probably going to look up more information and learn how to count and learn math and learn the correct way to figure it out, and either memorize the numbers correctly to answer it, or memorize the rules of math correctly to figure it out. So how does this example that seems very abstract and removed from real life experience, how does this apply to real life? For an example, let's talk about one belief that's highly contested in our world. Is the temperature of the Earth rising or not? Most people formulate this belief probably based on their influencers, the people that give them advice about their life, their family, their friends, the mentors and teachers that they have in their life. If someone runs from conservative circles, they have a lot of friends who are conservative, family members who are conservative. Their teachers and mentors are conservative. Majority of times they're going to be hearing the Earth's temperature is not rising, and thus that's going to be their belief, and that's going to be their answer. Now, if they're surrounded by more liberal circles, academia, they're probably going to come up with the opposite answer. If you're someone like me, who's surrounded by both at the same time, just based on other people, I would say, well, probably I had 60-40 in my head, and I would come up with that epistemic rationality answer. But then I say, okay, if I'm basing my beliefs off of other people, and I'm getting 60-40, then the method to answer this question by using the thoughts and beliefs of other people and then copying that and emulating that, well, that's probably not the correct way to figure it out, because I only have 60% accuracy, just like I would only have 60% accuracy if I believe the way to figure out if a number is even or odd is based on the shape of the number. So then I think, okay, is there a way to figure this out better? Is there an actual mathematical equation or facts that I can memorize? And then I look into studies, scientific studies. And scientific studies have a margin of error. If you look at statistics, which is a whole other discipline, and it's grounded in mathematics, you know that anytime you have a study, there's a margin of error. There's a percentage of wiggle room, whether or not something's correct or accurate or not. And within the margin of error, in the vast majority of studies, if not all of them, the temperature of the world has been rising. So thus, it has effectively the same accuracy. And of course, you never can be 100% sure, but you can reach a percent of 100% sureness when 10 out of 10 times you would make the same decision based on the information that you have. For example, you may only have 95% confidence that the temperature of the Earth is rising, but presented with 10 situations where you have to make a decision, like a political situation or a decision on whether or not you're going to recycle. If 10 out of 10 times you're going to recycle, you're going to vote for a candidate who believes that the climate is changing, that the temperature of the Earth is rising. If 10 out of times you're always going to do that, then effectively you have a 100. It's like you have a 100% confidence in it, even though technically you can never get to that point, because there's always going to be one study out there that says the obvious, or there's always going to be something outside the margin of error, an outlier. So that's how epistemic rationality works. It's about beliefs, and it's about how to update them and change them and have percentages, etc. And if your percentages aren't really good, then you have to come up with a different way of looking at the problem in order to solve it correctly. So to summarize, computers and human beings and other types of organic life forms think differently. They can think the same, but it's easier for computers to think in purely mathematical terms, whereas it's easier for living beings to think in more abstract forms, which are ruled by logic and rationality, namely epistemic rationality, which is rules about how to formulate and change and apply beliefs, and instrumental rationality, which are rules mainly based on experience about how to achieve a desired result and knowing what to solve for what action and what algorithm you need to go through in your life to get that result. And these things you have to understand prior to moving on to any other field of study, be it moral philosophy or sociology or psychology or political science. And thus I wanted to explain that before going on to my other videos where I talk about other things. So thank you for watching, and please subscribe.